we see these things, and we're filled with wonder. They're all examples of phenomena. Phenomena, observable events that occur in a natural or designed system. Events that we can explain with science. Phenomena inspire curiosity.
Hello, my name is Yung Justine Angela from BSP 1A.
Hi, I'm Anne Margaret Convita from BSP 1A. They look like flying saucers that drop into the water and froze. Ancient ice excavated jellyfish. In fact, these ice circles are frozen methane bubbles. Pockets of gas that when trapped underwater and frozen, form a spectacular landscape. Found in winter in high northern latitude lakes, like Lake Abraham in Alberta, Canada, these gas bubbles are created when dead leaves, grass, and animals fall into the water, sink to the bottom, and are eaten by bacteria that excrete methane. This gas released as bubbles and rises above. It usually just go above and dissolve into thin air, but in winter, that transforms into tens of thousands of icy white disks when they come into contact with frozen water. Yes, it's stunning but potentially dangerous sight. This is a powerful greenhouse gas around 25 times more effective at trapping heat than carbon dioxide being released into the atmosphere, triggering rising levels of global warming along with it. Methane not only warms the planet but also is highly flammable. Come spring, when the ice melts, the methane bubbles pops and fizz in a spectacular release. But if anyone happens to light a match nearby, the masses of methane will ignite into a giant explosion. Curious travelers can see these gassy hiccups in lakes across Canada's Banff National Park or in the Arctic Ocean of Siberia, where research have found gargantuan gas bubbles as large as 90 meters across.
I have one question for you all. Have you seen this picture on the internet? Do you know what it is and why does it release blood-like stains? This is what we call the blood falls. The blood falls flows from the tongue of Taylor Glacier onto the surface of West Lake Bonny in the Taylor Valley of East Antarctica. Unlike most Antarctic glaciers, Taylor Glacier is not frozen to the bedrock, probably because of the salt concentrated by crystallization of ancient seawater that was imprisoned. How does it produce the blood stains? About 2 million years ago, a hypersaline body of water became trapped beneath Taylor Glacier, which was isolated from light, oxygen, and heat. The water contains a high amount of hydrospheric oxide. The iron in the water comes from the bedrocks below the lake. As soon as the iron-rich water comes in contact with oxygen, a complex chemical reaction called oxidation occurs. The result of the chemical reaction between iron and oxygen forms the reddish particles that we see, wherein the iron in the water rusts, leaving crimson trails on the glacier's hard surface, reassembling bloodstains. It is truly a visual and scientific wonder, and Taylor Glacier is the only place on Earth where you can see it.